Our final speaker before the break is Rich Porter of Graphcore, who is one of our sponsors today. He's a director of Silicon Verification. Rich has 25 years of design verification experience in both startups and large organizations. He spent his first 10 years in the industry running RTL, until we realised that all the interesting work was in verification. It's incredibly diverse to Silicon Verification.
Great. Mic okay? Can you hear me? Yep. Okay, yeah. First of all, it's great to be back. Just like to thank Mike and Sarah and Bishop for organising this. It's good to see everybody here as well. After 2 years, I think we've missed out, so that's a good start. It's great. So yeah, as Mike just said, I'm Rich Porter and I'm director of Silicon Verification at Graphcore, which happened since the beginning. It's almost 8 years now. And for those who don't know, Graphcore, it's a machine learning silicon startup, office and design centre in Bristol. We've also got design centres around the world: Beijing, Cambridge, Oslo. Why should you listen to me today? Well, hopefully I'll say something interesting or controversial, probably both. So yeah, Christmas. We've had the early Christmas. 200 days to Christmas exactly today, apparently. We're taking shopping dates nowadays. I've always been in the opinion you don't ask, you don't get. So, you know, I'm going to run my Christmas kids. Just a bit of background here. So this is a chemical model I use for verification. Experience soft and hard verification. Hard verifications, specifications, verification planning. Statistical, that's all stuff, you know, it's the real nuts and bolts of conventional verification. And then there's the softer side of things, another process, integration, infrastructure, tools and practices. Tools and practices that we're sort of constantly adopting from software engineering. You know, so it's like, you know, engineering the best product, so the best product outcome, and also best practice. So I'm going to talk more about the sort of soft stuff today, as opposed to hard stuff. So the first thing, number one on my Christmas list, I want more licenses and task tools, because the way that using VA is changing. So the problem I've got is contemporary verification teams are changing the way they use instruments. What I mean is that the adoption of software practices like continuous integration, shift left of integration, shift left. But also greater integration of commodity hardware. So there's more CPU cores available than that. Just make sure we're talking about the same things. What do I mean by continuous integration? Well, it's something that so you can use stone from software from DevOps. What we're going to do is we're going to encourage all the contributors to make small changes, some very small, and we're going to automate a suite of non-regression tests. A set of tests to check that the head of our repository is still working. If you haven't introduced any regressions, by those changes. And also potentially we're going to gain a merging of those changes into the repository on the success parts of the test. So what we're trying to do is we're trying to continually improve the quality of code in the repository. At least we don't want to progress, we want to also send it better. We're also going to add tests as functionality added to make sure that any subsequent changes but what we need here is an always working repository model. So head of the repository always has to work, has to pass those tests, because otherwise if we layer some changes on top, run the test set, and it doesn't work, we don't know whether those failures because issues were in the repository or issues from other changes. And what's going on in that test set on changes, we're also going to run every hour. We're going to run every night, perhaps more. We're going to have run every week with perhaps even more tests. And yeah, something else is idea of mono-repository versus repository. Where we've had a source code repository to get this version. And what we've got with the mono repo is we've got all the projects in a single repository. You know, it could be multiple chips, or chipset. And this is opposed to repository of repositories, where we might have separate repositories for each block. So we've got smaller scope of each of those repositories. But then we need another repository on top to just contain versioning information to point to which versions of those smaller repositories are expected to work with each other. So, yeah, here's my view of it. And on the left, we've got mono repo, so we've got blocks A, B, and C, some common category constructions, all in one block, all versioned all at the same time, and then we have the head of assets, basically. On the right side here, we've got the repositories, all those blocks, these separate repositories, all changing asynchronously. Another repository on top. Those repositories to detail which versions of care will. So there's advantages and disadvantages associated with both these approaches. With the mono repo, you know, we're getting shifted out of the integration. So with our test set to its integration, we need to check that everything integrates at chip level at every version. Disadvantages of that is you get much increased continuous integration workload because you've got to do those tests and run those tests at the time. Another disadvantage is that engineers need to know about everything, so they may make some changes in one of the small blocks and it may cause a failure elsewhere. They won't recognise the failure, they might not recognise the tool. So what they need to know about doing their job in space. Repositories, so you know, individuals can work very efficiently in smaller repositories, small scope, so we're doing small SDI environment. But keeping the chip level working is a much harder problem because the time has to go long high work out which work each other. It could be an advantage as well. Here's the disadvantage is the engineers are siloed, they just work on some small part of the design, don't do much. So Graphcore, we're going to reload the advantages of the mono repos that we use, but unfortunately the mono repo continuous integration generates a very high compute burden. But interestingly, most of this is non-novel work. So when we're changing something, we're not changing everything, just changing a tiny bit of design. But it's really difficult to compute the test subset based on those changes to know, you know, which tests those changes are going to affect and to show. Here's a metal. But we do know what the quality of the repository head is very well known. Now, the regression set, and obviously we get the shift left of integration. And we also get to keep previous generations alive as they have the same repository. So any infrastructure carry forward into our previous designs and we run simulations of those if we have to. Another thing is that this workload is changing now. So we're seeing an expansion of continuous integration just beyond functional replication. So it's not just it's not just static for synthesis, equivalence, clock reset, main crossing, DFT, link type checks, test the test infrastructure, we test the test generation, we have tests check performance of simulations to make sure we haven't introduced any regressions into the simulation performance itself. And so I need more licenses for everything. This isn't just about simulation, static performance. But the thing is that this is non-novel work. I'm not actually doing multi-service. I'm not doing anything new. It's the same files, the same tests. And then also we've got this as well, so Henry Moore's law, say that, and large scale. So, you know, back in the day when I was younger, if you want more performance, you just went and got the latest processors and you went past that. But that's not what's happening anymore. When we buy a new service today, you get more CPU cores. But the single-threaded performance of those CPU cores remains pretty constant. I can't run anything faster on it, just more. So yeah, you get more cores by default. This is driven by not a chip module, chip on wafer substrate. Chip on wafer has a link here actually to AMD Milan X, which I think may possibly give us a step function. But yeah, even if I do want to get some more machine, which is not the lead times, increasing cost, just not getting the thread performance boost. Yeah, and there's also this sort of platform versus pet. So I always used to say that you should treat a compute farm like a new machine, to take it over, and put the new ones in. You know, that's just not happening anymore. We should be treating our computers more capital. We shouldn't be retiring them to pasture. We should just be hammering them until they die. We actually take them around the back of the barn and put them up in misery. Yeah, and there's also I think they're going to have a chat with Scott afterwards about this. Risk concerns as well, so which is stuff happening here. They potentially have education, and I suspect they have lower power per unit simulation. It costs less to run simulation than ours, but it might take longer. So when I'm running my contingency strategy one, I still need the lowest latency. I've got engineers waiting the results and when that was happened. Quick jobs to old machines, long pole jobs to fast machines. Yeah, but should I also have to optimize for licenses? Yeah, I just have the licenses on. The cost of energy is increasing. CFO hasn't, he hasn't done like Scott, CFO hasn't done like us yet. I don't know how much money that can be recently. It's not an issue. But I still want faster simulation. You know, I'm not going to trade more licenses for geometry simulation. Any tool, speed improvements, I still want that. Because I want to get to the point of failure as quickly as possible. But so anyway, so the summary here: scale workload requires lots of compute, correspondingly high license counts. But the interesting property is most of what I'm doing isn't new. So I'm just doing the same thing again and again and again, just checking that. And also, there's opportunities to use lower power processors to increase the CFO. Potentially more licenses, then I'll have to optimize the license usage. When should I get rid of my own computers? I'm not really sure. Okay, so second on this is I want a common logging API. So I want to preserve the log message semantics. Problem. So EDH will flag the message semantics from text. Here's an example. Log file, which I believe is something similar. Take it apart. Severity, some identifiers, identify that type of message. Potentially have file name and location within that file, and some other attributes in this case. But the tool knew all about this, and it's text. And I've lost that information, and I've got to put it back together. I've got to extract it, potentially by using some aeroprone method, which is probably going to involve regular expressions to get it back. I get hampered by inconsistencies, formatting, doesn't always come out the same, variable line breaks depending on the identifiers, it's come for error in roles because element somewhere that isn't necessarily an error, excessively chatty messages, that using up processor time, sending down, change sessions, which are and also, the infrastructure I have, that's generating messages as well. It's all mixed in, it's all out, but it doesn't always come out the same order. But the thing is, the tool had all this information, and in fact, it was text for him to read, but I'm running all of this from the machine. And I can put it back together again, and I have millions of logs because I'm running so many jobs. So what I want is, I want to avoid, missing real errors. I don't want to try and bug my parser. Or over sign off, regular instruction, that signs me off. Sign off, targeted, is describe and review, which description and also test. And I want to automate triage and of course millions of tests. I want to try and find that for one group by severity, the message, where it's at. So what I've got at the moment is obviously got the tool, these my touching hard using regular expressions. I've got my sums going in, I've got formats. If I'm lucky, the tool will ship a file. Message descriptions in there, try and let's engineer them. Sign off process. Messages. What I like is, well, I want APIs to interact with those two messages. I want to use a callback, I don't want to use a touch path. I want a callback, and the message is generated, and I want all that information to be given to me in that callback. So I don't have to bug with reverse engineering, split extract information. It's also nice to have access on management, so I can decide to put tools finish. I can decide tools finish. So at the end, callback, and actually using the message format, and actually using all the solution type. Previous implementation. Case I have more picky, TwoAPI define, I'm sure I can extract JSON XML from that. If I go back to my example again, it's in JSON that I can timestamp. So we go back all easily accessible, so I can sign this off without having to pass the full message. So doing automated triage on all these tests and group by and also want to talk about TwoAPIs. Why do I still have to use TCL to program EDA tools as well? All my infrastructure is in another language. So I can't reuse or code my infrastructure in the EDA tool. I want to program in the EDA tool. I don't believe that TCL is well suited to my infrastructure, even though I know it's developed by specific. Newer, faster, more fashionable services are choose all those. Is TCL going to last forever? No. But I could ask my EDA vendor, I could say, hey, I don't need TCL, give me something to use in instead. But I'm just doing future. But I could ask for CAPI because it's C, which is so we invest still, the tool can have a CAPI and comes from distributions of languages. I use that API, so I've got a choice that I can use. So I can use my own, I can build my own when I use a previous version. So there isn't kind of like a precedent for this. Verilog's got VPI and can sort of emulate the much of the TCL interface in the simulator using API, we do this. Graphcore, it's not a real lot of thing. We've done that times before. So I would like to be able to fit my preferred scripting language to any mediator so I can reuse my infrastructure code. To have a CAPI as a tool so that TCL interpreter shows popular languages of those and utility TCL backwards compatibility. So once again, Graphcore, we've managed to do this using the TCL API. We can pass TCL commands and objects to and from Python, or we reused our infrastructure in a static form. Not much to do yet. So the summary here, tools, serialized structure-based text, and how to see that data preserved, messages less overflowing, simplify styles, use less processing power, improving accuracy of automated triage. There's actually two APIs, speed linkage, will allow you to use edge, which runs on. Okay, so I want more alternatives to UVM and system variable functional coverage, or at least have a non-HTML ratio. Here's the problem. UVM, Marmite, banking bars, spreads. Like you love it or hate it. Some people won't use anything else. If it's not UVM, it's not an application. Other people are burned by it, refuse to use it. Interesting observation, but I think the real problem here though is that system variable is not shown. It's not, it's a parallel to the language. This always tells me that it's several languages cobbled together. 2005 for class-based system variable. System variable solution, something strategy, functional coverage, as we just said. There are labels that exist, it's not like these, but they're all still built on top of HTML. So what I'm advocating is the creation of verification frameworks with general purpose languages, so able to make mixing with verification general purpose infrastructure. We're using infrastructure, that's going to make that easier. Excuse me, I get the library support of other languages. Performance. There's a lot of people working, for example, on Python, other languages. It's much larger online community. I think Stack Overflow, if you Google tokens and system variable, you're going to get limited. You're going to get limited search results. Obviously, C++, Python, all. Obviously, we want to keep the simulation tools, the logic simulation, the bus function models, and they are parallel tools to try and do those in another language. But yeah, what's to say that it'd be very unwise to change the current architecture we have. So, test simulation functional coverage is best practice architecture. So, that's Graphcore, coverage. Changing that. So, yeah, there's an example of this. You may be aware how UVM is a thing, so it's attributed to UVM implementation, Python, KPI, but of course it doesn't have to be UVM based. It could be more than one framework. Obviously, different types of verification. I've always felt that CPU and ASIC style verification are very different. And it could be useful to have frameworks that specifically target different types of verification. Better support for offline test generation. You can do it with a simulator, but I suspect it's not framework. Better solutions to that. Yeah, and then also functional coverage. I see this as a separate coverage library. It allows introspection coverage. Look at coverage dynamically. generate documentation from coverage, check the coverage off, hit coverage, all sorts of interesting stuff we could do. And it would also allow us to apply some functional coverage to other parts of verification. So back in the day, Graphcore, we wrote debug structure set simulator with a text generator that wasn't written in system Verilog. We used one system Verilog function coverage to extract metrics from the text we were generating, and we successfully found the issue in the structure set simulator. No system Verilog simulator inside. Yeah, and also coverage analysis also focus on coverage, so we can determine we develop a lot of coverage analysis tools to look to see what we are not hitting. The separate might encourage a community to coverage. So yeah, somehow not cool. But you know what I'd like to see is non-HDL based verification frameworks to enable mixing of verification and other general purpose languages we need for infrastructure code. Yeah, and also remove functional coverage from the simulated. So it's actually widening the use of that into non-simulation environments. Okay. Key takeaways from this then is I need more EDA licenses to run CI on computers. Better way of determining if a test is passed or why it's failed. We need more choice of verification.